Welcome to BobMath. In this video, we have a new exercise for geometry. Well, our exercise is as follows. We consider the figure as its side such that we have a large semicircle with diameter AB and small semicircle with diameter AC. And we have the straight line DE tangent to this small semicircle at point F such that this distance ED equals 8. So the questions is as follow. Calculate the blue area. Before discussing the solution, try to complete the exercise to increase your skill in mathematics. Then complete the video. We consider point M to be the center of the semicircle with radius r, and the point O is the center of this small semicircle with radius x. We have ME equals MD because the array radius. ME equals MD equals R. Let the straight line passing through the point M be perpendicular to the straight line DE and intersect the distance at point G. So point G is the middle of the segment ED. Then GE equals GD. So GE equals DE divided by 2. So GE equals 8 divided by 2. So GE equals 4. We have it according to the from OC equals X. So FO equals X. We also have straight line DE tangent to the small semicircle at point F. So the angles FGM equals 90 degrees and OFG equals 90 degrees. Therefore, FGMO it is rectangle. So MG equals X. We have a right angle triangle MGE at point G. So ME square equals MG square plus GE square by Pythagoras theorem. So R square equals X square plus 4 square. So R square minus X square equals 16. We call this inequality alpha. From the figure, we have the blue area is the area of the large semicircle minus the area of the small semicircle. Let S0 be the area of the blue region. So S0 equals R square P divided by 2 minus X square P divided by 2 equals P divided by 2 times R square minus X square. So from alpha we conclude that S0 equals P divided by 2 times 16 equals 8P. Therefore, S0 equals 8P. Thank you for watching, and please don't forget to subscribe to my channel for more exciting videos.